Hey guys, today what we're going to be doing is examining slope in context. So I'm going to give you a scenario and you got to come up with a real world context on how this applies to it. So let's go ahead and look at this together now. So every year the San Diego Fair is in Del Mar, and there's two things you have to pay for. You have to pay for to get in, and you have to pay for money per tickets. And you're going to use these tickets to ride rides. So the San Diego County Fair, just to walk in, even if you go on 0 rides or buy 0 food, it costs $10. And then it costs $2.50 per ticket. You use these tickets to go on rides. So let's go ahead and figure out the total cost. So if it's $2.50 per ticket, and you're buying 5 of them, after that you still have to add your $10 to get in. This would be a total of $2.50 times 5 is $12.50, plus 10 is $22.50. Same idea. If we did 6, it's $10 to get in, plus $6. 6 tickets for each ticket is $2.50, which would be a total of $25. If we continue doing this, if we increase our tickets by 1, we'll increase the amount of money we spend by $2.50. So I know this would be $27.50, and I know this would be $30. So now after we have our table, we can graph it. And remember, if I go on 0 rides, we need to label our X's and Y's so we know what we're talking about. So this is the number of tickets we buy. And this is total cost. So if I go on 0 rides, so I buy 0 tickets, I still need to pay $10 to get in. If I buy 5, I want to spend $22.50. If I get 6, I'm going to spend $25. If I spend 7, it would be $27.50. And 8 would be $30. So this is my graph I have right now. And it does ask, should the graph be discrete or continuous? As a reminder, a continuous graph means you can buy any amount of tickets. I know you guys are thinking, oh yeah, you can buy 1, 2, 3, 4, 5 tickets, but think about this. Could you buy half a ticket? Or could you buy 0.5 of a ticket? Can you buy 0.7 of a ticket? The answer is no. You can only buy a whole number's worth of tickets. So when that's the case, you cannot buy a fraction of a ticket. So this graph would actually be discrete. And that means that instead of having a straight line, we would just have those dots. If you have a straight line, that means any number on that line could be an answer. Here it's only whole numbers. Okay? So let's go ahead and look at this. State the slope of the line. What was my rate of change? What was I increasing by? So if we looked at this, we had the equation of the total amount of money I spend is $2.50 a ticket plus $10 to get in. So my rate of change is $2.50. It's the coefficient of x. That's my slope. And what does it represent? For every ticket I buy, the cost increases by $2.50. $2.50. State the y-intercept. What does it represent? So that was the plus 10. And that represents the $10 to get into the park. So that represents the price of admission, price to get into the fair. So even if you go on 0 rides, you still have to pay $10 just to get into the fair. All right, so let's go and look at this. Define your variables and write an equation. We kind of already did this. I had y equals total cost. And I also had x represent number of tickets. Number of tickets. And the equation was there. The total amount of cost is going to equal $2.50 I buy on a ticket. I don't know how many tickets I'm going to buy, so I'm going to put x. But I know I have to pay $10 just to get in, no matter what. Now, if a family of 6 wanted to go to the fair on Saturday, each of them planned to ride 10 rides, which means they each need 10 tickets, what would be the total cost of the family? So what would be the total cost if I have $2.50 a ticket and a ticket plus $10 to get in. But the problem here, guys, is it's $10 for one person to get in and $2.50 per person. Okay, so let's go and if this is just one person, this is just one person right here. They say they want to go on 10 rides. Well, the total cost for one person would be $2.50 times the 10 rides plus $10 to get in the park. That would be $25 they spend on rides plus $10 to get in the park, which means the total amount of money they would spend is $35. Now, this represents one person, but this says if a family of 6 wants to go. So if this is the total for one person, what we're going to do is multiply that by 6 to figure out how many people would go if, how much that would cost if 6 people ended up going. So if you took up your calculators, or if you could do this on a separate sheet of paper, 6 times 35 would be 210. That means the total cost for 6 people to go would be 210 instead of just 35 for one person. All right, last thing, it says writes the context to represent a proportional relationship. Now, if we remember this, proportional relationships need to contain the point 0, 0, and they need to go, which will mean it will go through the origin. So if I look at this, my original equation was y equals $2.50 per ticket plus $10 to get in. That $10 to get in makes it not proportional, which means we need to come up with a story where we don't have to pay $10 to get in. So what the equation would look like for a proportional relationship is this. Y equals 2.50x, $2.50 per ticket. So what this would look like then is there is no cost to get into the fair because there is no plus 10, it's gone. There is no cost to get in the fair, but to get in the fair, but it costs $2.50 per ticket. $2.50 per ticket for rides. All right, guys, hopefully this makes sense. If you have any questions, please feel free to email me or your teacher, and have a great day.